In this video, we're going to take a look at some applications of logarithmic functions. So you might notice the handout is already filled out. I actually already recorded this video, but then there was a problem with the file, and so now I need to record it again, but I've already filled in the sheet. So we're just going to walk ourselves through what I did to answer the question. So it says the age of a rare baseball card can be calculated using the equation shown below, where A at V is the age in years of the card and V is the current value, it should have said in dollars, of the card. And then our formula here says A of V equals 5 log base 3 of 1/2 V. So it asks us to graph the function using transformations on the grid provided. So the base function of this is log base 3 of V. So I chose to put that on the middle table. You only really need the log table and then the transformed table, but we do also have that extra table to help us if you need help getting your points. Now I did have the tables labeled with X and Y just out of habit, but I changed them to be V because V is where the X is, and A, which is what we're using instead of Y. So for log base 3, it is sometimes difficult to come up with good points for that. So I instead used the base of 3 and I calculated a table for 3 to the power of V. So I used the numbers from -4 to +4, and then I did 3 to the power of each of those numbers. So 3 to the power of -4, a negative exponent makes a fraction, so I did 1 over, and then 3 to the power of 4 is 81, so I got 1 over 81. And then 3 to the power of -3, the negative exponent makes it a fraction, so I did 1 over, and then 3 to the power of 3 is 27. 3 to the power of -2 was 1 over 9. 3 to the power of -1 is 1/3. 3 to the power of 0, anything to the 0 is 1, and then 3 to the power of 1 is 3. 3 to the power of 2 is 9, 3 to the power of 3 is 27, and 3 to the power of 4 is 81. To get our log table, we take our X and Y columns, or in this case V and A, and we trade them. So my X values from 3 to the V are going to become my Y values for my log function. So I just copied them over, and then the Y values became the X values. So I just copied those over. And then to do the transformations, I thought about what was happening in this equation. There's a 5 in front of the log. That's our A value. So that is a vertical stretch of 5. So I took A, which is my Y values. Vertical changes your Y values. And I multiplied, because when we stretch, we multiply, by 5. And then for the 1/2, that one's inside the bracket in front of the V. So that's our B value. That is going to be a horizontal stretch. It looks like a compression, but the bracket's always backwards. So that's a horizontal stretch of 2. So horizontal changes our X, or in this case, V values. Stretching, we multiply. So I multiplied my V by 2. So I actually did the A values first. I took each of these numbers in that A column and I multiplied them by 5 to get -20, -15, -10, -5, 0, 5, 10, 15, and 20. And then I took what was on the V side and I multiplied those by 2. So I had to use my calculator here, and I ended up with some decimals and some non-decimals. I took all of the numbers that would fit and I put them on the graph. So obviously my x-axis does not go past 20, so the 152 and 54 did not fit, but I did the 18 and 10, then the 6 and 5, then the 2 and 0, and then I had to estimate where 0.67 and -5 was, 0.22 and -10, and then that was the last point that I could fit. So I did notice that we were approaching 0 here, so I drew in a vertical asymptote at 0, and then I drew in the curve. Okay. Feel free at any point to pause the video, finish filling things in, but I'm going to keep talking my way through the other parts of the question. So for part B, It says determine the age of the baseball card if it is currently worth $200. So in the question we have A and V. A is the age, V is the value. So the $200 would be my value. So I took the equation A at V, and everywhere I saw a V I put in 200. And then I said it was 5 times log base 3 of 1/2 V, so I put in the 200 for V. 1 divided by 2 times 200 is 100. Log base 3 of 100 is going to be a decimal. 100 is not a nice power or a perfect power of 3. So I knew that on my calculator I can only do log, which is log base 10, and ln, which is log base e. So I needed to convert it into one of those two bases. I chose ln. So I used my change of base formula, which is in your green package, and I did ln of our argument, and then I had to divide by ln of the old base that we were switching out of. So then I did 5 times ln of 100 divided by ln of 3, and I got approximately 20.96. So it is 20.96 years old. Like I said, feel free to freeze it if you need to at any point. Okay, so then it says, how much will the card be worth when it is 30 years old? So as I said, A is age and V is value. So 30 years old, that would be my age. So in the formula this time, I put the 30 in for A of V, and then it equals 5 log base 3 of 1/2 V. And we need to solve for V. So we have 3 main methods we use for solving. We can rearrange, factor, and use quadratic formula. So in this case, I only had 1 log with 1 variable, so rearranging seemed like a good idea. So I started with addition, subtraction, didn't have any, then multiplication, division outside of the bracket. So I was multiplying by 5, so I divided both sides by 5 to get 6. And then to move the log base 3 to the other side, the opposite or inverse of a log base 3 is a power with a base of 3. So I took that 3 to the other side and did 3 to the power of 6, which now equals 1/2 V. You can divide by a half, but I think of this as multiplying by 1 and then dividing by 2. So I multiplied by 2 to get that 2 to the other side. You could then think about either dividing by 1 or we're doing 1 times V, but it's insignificant. So all we really had to do was multiply by 2 to get 1,458. So it will be worth $1,458. Okay, that's it for our log function application.